Alright, we're back streaming after a month. So, we're continuing our journeys with Johnny, the humanoid. AI next from High Wonder. And isn't he beautiful? Cool. So, many things to discuss. I'm going to continue in my public Notion page here. You can see here. And I've been cleaning things up, what I'm doing, Johnny, the humanoid from High Wonder, and everything else. I'm trying to get expertise in teleoperation, motion retargeting, learning from imitation, motion planning. I'll even add reinforcement learning in there. That's coming up. A lot of things are coming up. Motion planning, trajectory optimization, kinematics, dynamics, grasping, visual serving, simultaneous localization, and mapping. It's a lot of different things. So I've kind of split things into 3 months here. I got Johnny in November, Johnny the humanoid. Got a lot of work over Christmas done, Christmas holidays, and January. Let's go here. So I created a plan for this stream. I did 2 streams before, one on November 12th. Click here, show it. That's when I was unboxing Johnny. It was Wonderful Beginnings. I didn't have so I received it in the box, and that was the first stream. And then also the second stream was on December 11th. Covered many different things there. Again, humanoid hype and going to the Humanoids 2024 conference. And I was showing Johnny and all the joints and servos, different degrees of freedom again. Turned them on, ran him with the PlayStation controller, which I'll show again in this stream. The app, some of the code, some of the actions, teamucks. And I mentioned some things that we can show next time. So let's go to this stream then. This is what I would like to cover today. A bit of like soccer playing in general and what Johnny can do right out of the box with soccer. Show that. Dive a bit deeper into how it works. I might lose the stream once I SSH in. I made that same mistake in stream 2. But before we get there, I edit these for YouTube so I can join the 2 separate streams once the internet comes back from SSHing into Johnny. Before that, we can talk a little bit about kind of the dream of RoboCop. There's these like many different types of robots that have been competing ever since 1996, and it's very funny to look at. DeepMind actually came out this year and completely changed the name of the game by being much faster and better at soccer. That's the power of reinforcement learning at scale. But it's a lot of fun to watch. There's different leagues, different sized. You can have kid-sized, teenager-sized, adult-sized leagues. You can have even non-humanoids, these kind of fast-wheeled robots. It's very funny to look at some of these playing the 2024 league here. And these are the now robots playing. So yeah, they have the goal of beating the best human team in 2050. And I've had lots of bets with my friends of if this is even possible. Could a robot ever be better than Messi? And all the details of, is it even dangerous for humans to play against metal robots? And they're always falling up and they know how to pick themselves up. These are the standard platform, but there's many other teams that build their own robots. For example, here, Team Romula in the finals here, UCLA. And Sven Benke in the workshop was saying it's kind of sad that nowadays they always need these humans behind it. They're scared of breaking the humanoids in case they fall, so that's why they have the team behind it in case they fall. Nimbro is the team from Sven Benke in University of Bonn in Germany. We're going to meet some of the people there at the workshop. But you get the idea. They're getting bigger and better. This is still kind of lame and laughable, but wait till I show you DeepMind's results. DeepMind soccer. These are much more impressive than everything we've seen before, mostly just due to the power of reinforcement learning. They first used the motion capture system to get the state of the game, but later they actually then were able to train with just first-person view in simulation and then transfer to the real world. And like, what a goal! It's just these little kind of penguins playing. First they're using motion capture. What a goal as well! It's just very impressive, the power of reinforcement learning if you just optimize towards reward of actually getting the max reward, which is the max number of goals. Anyway, so that's kind of RoboCop, that's DeepMind. Talk about that. So I was in the Nancy 2024 workshop, soccer workshop, for the full day for the first full day of the workshop, so Friday. We met a lot of interesting people there, but this was the workshop page, and there's many different ways to tackle the problem. Things are going slowly, bit by bit, more towards the learning, how to learn how to play soccer or how to learn specific subcomponents. So, but typically what was done for decades is kind of motion planning and state estimation, perception, all of this, simulation. There was the Roban team from France. This was the Sven Benke's team. How to just, from zero to robot, how to get from actually building your own robot. It's very impressive what these people are able to do. Build their entire robot hardware. It's highly complicated. And then also the software to make it play good soccer, good football. There was also LeRobot from Remy Gadin. He used to work in Tesla, and then he now works with Hugging Face, talking about how to train imitation learning for arms to pick up things or for locomotion maybe. So 2 different talks on how to plan for footsteps using reinforcement learning. So it's a very specific subcomponent of where do you place your feet. It's really nice pictures here, like where do you want to put your feet on the way to getting to a specific pose. It's very interesting. Here's an example. If you want to get to behind the ball to then kick it in the goal, you have to go all the way around in front of the ball. So all these hundreds of sub-problems within football. Later, after lunch, there was like Anthony Raffin, who built the Stable Baselines reinforcement learning library that I've been following, how he was able to learn how to make a quadruped do locomotion, like go forward, backwards, left and right. There was also reinforcement learning for fall recovery and stand-up. Typically, it's done by keyframes. I showed that in the last stream. But you can actually get better performance with reinforcement learning, a better policy for standing up and even before even falling to protect the servos and joints, to like the same what humans do when we're about to fall. We put our hands on the ground to prevent any damage to our face, for example. So it's important for robots to do the same. And then there was this Booster Robotics. They've really keep improving their humanoid that's worth $30,000. This little guy, and it was in Humanoids, Nancy, and this is the conference, by the way, that I was at in Nancy, France, November 22nd to 2024. And just this little guy, he was coming around trying to pick up rubbish in his basket while we were having lunch. And you can see all the different degrees of freedom that we talked about last time, but there's probably more degrees of freedom. Similar to what Johnny here has. Like hip, pitch, roll, and yaw. Yeah, three degrees of freedom in the yaw. In the hip, 1 in the elbow. So that's typically how humans do it. Johnny, for some reason, has 2 degrees of freedom in the elbow. Anyway, this was a really cool robot. It just shows that things are getting cheaper and better and faster, and they're now could become a standard platform and be used a lot in the football. It was used in 2024, the RoboCup League. And then there's loads of other non-learning based approaches like state estimation, how to use foundation models in vision, even for like multi-agent coordination, like how do you optimize the 4 or 3 robots on your team to work together. 1 is defending, 2 are striking or attacking, how to plan for that. And then Sven Benke kind of talked about the last 20 years of him competing in RoboCup, and he's kind of happy on one sense that things have progressed somewhat, but also unhappy that things are not progressing as fast as possible. And he wants the G1 Uni3 robot, if he can get it, if the sales and manufacturing increases, to replace their Nimbro robot. Because at the end of the day, most of the problems here are software problems. Yes, the hardware can limit you, and yes, better hardware gets you further, but at the end of the day, the software is the limiting component, in my opinion, and there's many arguments I can give for that another time, and we'll keep seeing that. That's why most of my plan here is to talk about software in my humanoid journey. Hardware matters. One day, hopefully, I'll get a bigger humanoid than Johnny, but I can't afford it yet. But Johnny can do many things, but the software limits him to do even more. Obviously, only 5 degrees of freedom in the arm limits you to be able to not do many things. Obviously, his size limits him, but there's many things he can do with simple arms, as actually Remy Cadine from LeRobot is kind of convincing us with this like S100 LeRobot, what they're able to do with these tiny arms. Let's go to the LeRobot page on GitHub. They're able to train these to do even laundry sometimes, but usually simple tasks of just diffusion, picking up cubes, passing things between two different arms. I mean, there's the classic, this kind of putting a battery inside. This is imitation learning. So a human first is controlling with the leader arms, so then the follower arms are able to do the thing. It's like the ALOHA based approach. Two cameras on the grippers, two different arms, and just it's about putting the AA battery into the slot. You can see all the different, this is the LeRobot dataset. You see all the joint angles for each of the two arms. I think it's 7 degrees each, one for the gripper, including the gripper. So that's kind of putting everything into a context that humanoids have a lot of technology, a lot of different software components and coming together. Cool. I'm going to have to SSH in, which is going to block the stream and create another stream, but I'll edit them together for YouTube. So typically what I do is checking if we're back, reload the player, and we should be back. So I SSH'd into the robot, which causes me to join the access point of Johnny. Next stream, I will just do it before the stream, but we're back live. Okay, we have Johnny. If I press up, turn the PlayStation controller on, let's see. Yeah, he's walking, and he has that weird arm position, which could cause him to fall. That's not by default, it's just a bug in the code. Anyway, I'm going to change all the code and the arm won't be like that when I put him on the ground. So, let's see. I'm controlling the controller here. Too much weight forwards, he's almost falling. Okay, he works. Now I'm SSH'd in so I can continue with my plan. In, we run a Docker container that is always running and the robot is on. And we're inside the Docker container, and I typically run bash run tmux, which is my own bash script to kill all the ROS processes. It's an improvement from last time, and we start a tmux session terminal multiplexer. On the top we have ROS core, which is just the typical thing in robot operating system to have a ROS master running. We're ROS noetic at the moment, still ROS 1. And here we're running probably .base. Base.launch. Let's see what comes with this robot in terms of soccer, football. I go to the kickball folder, make this bigger, and if I just do ROS launch kickball node, let's see if it plays soccer. And I'm going to run it. You see it a bit, but now I'm going to swap to the bigger screen here. Is it playing soccer? Left foot kick, nice. Let's get that ball. So now he's like looking for the ball. And we can put a ball here. See if he ever finds it. He's doing a bit of rotation. You could make his... Oh, has he seen it? No. Or he's looking at my pants maybe. No, he's completely blind. We can help him out a little. He's seen it. Left kick again. He's kind of following it with his head, and he'll keep kind of going towards it. But if he loses it, he'll try to find it again. I think he's found it. Who's a good boy? Left foot again. He kicked twice. 3 times. Okay, so pass it. Pass it to Papa. Pass it back. So this is a visual servoing based approach. It's not motion planning, there's no state estimation. It's just finding the HSV purple ball or even blue ball, and this is close enough. And close enough in color. Tracked it pretty well there. Here, got a bit confused there. Can we get a right foot kick? So yeah, there's limitations, but it's surprising that it works at all, given what came from the company Highwonder. I think it might be seeing ghosts. I'm gonna open Orviz. Yeah, if I show you in Orviz, you can see it's first person view. And on the top here, we're seeing this purple ball around. Didn't see it. But that's how the HSV mode works. It's not that good. Not too good state estimation. But I think you get the idea. So let's Control C the kickball node.launch. Typically I'm using cursor, which is like VS Code, but with LLMs to code. And I can actually go into the Docker container that is running on the Raspberry Pi on the robot. You can see he's going to stop to middle of a walk. When I Control C, he's in the more balancing on the left foot. And now I'm actually inside the Docker container on the Raspberry Pi of Johnny. Cool. So I've showed you kind of multiple different approaches. So let's kind of classify these. So like RoboCup typically was motion planning plus stage estimation plus control. Usual robotics pipeline. Sense, think, act. Often one way to think about it. But DeepMind's latest results was just pure reinforcement learning from even pixels eventually, their second paper. First, motion capture, well, just pure reinforcement learning. I think this is like a very deep philosophical point here. What will work over the long term, even for useful robots in our home? Can pure reinforcement learning scaled work in the home? We'll see. So first they used motion capture, and then later purely training from pixels from the front camera, similar to what you were just seeing in Orviz. Johnny is more of a visual servoing approach, which is even more simple. And how I describe visual servoing simply is, very stupidly, I say if ball to left, rotate left. There's some details in the middle, but that is what it is on some level. You have to check like how much should you turn left. There's lots of PIDs involved in that. Obviously there's a bit of complexity with Johnny. He has a head, so he's not only moving his head left to look at the purple ball, but then you have to decide based on where the head is looking how much to move my body to face it so that we get either his left foot or his right foot to the ball. And that is complicated, especially how sad to say that how Highwonder coded this football visual servoing code. It's highly, I would just say, bad code, and it's taking me a lot of time to deconstruct it, and many times I've thought I should rewrite it or just use it and keep trying to make it more understandable, change all the variable names, add more functions. But I'll get to that later. So we've covered RoboCup, we've covered the fancy soccer workshop, which is amazing, and we've SSH'd in, talked about the Docker container that's running, cursor ID access to that Docker container, and my run tmux script, which creates these panes that you see here. And the only thing that's running is ROS core. We have Orviz, nothing's running, no images are showing because I killed the kickball node launch file, and we ran kickball node. That was the last thing that ran here, ROS launch kickball node.launch. And that's what comes out of the box. Should I go to that now or go to these other points? Yeah, let's maybe just have a little quick look at that. So kickball node.py. What do we have here? Here's the full repo, by the way. Source has many different packages, and inside example, inside scripts, inside kickball, we have kickball node, and I've been modifying kickball without kick node as what we'll get to later is for sock picking, which is the real thing I care about, not soccer. Socks, picking up socks is semi-useful. Soccer, that's a more pastime, fun activity. And the road to socks will then get you further. Maybe one day you can pick up all toys and rubbish on the ground. But first things first, soccer. Let's try and understand this. Basic imports, ROS imports, and then specific to AI next from Highwonder, this code. and there's different actions for left shot, right shot. I showed that in another stream that I actually mapped I think the X button on the PlayStation controller to the left kick or right kick. It's just an action that we can run. Lots of little details I can get to, but I don't want to drown us in details. Generally, there's this approach object class that's how we approach any object. Let's see if I can open that. This is for finding any kind of XY pixel location and using that to walk towards that. So I actually created come to papa with this, and you can also follow the ball, and you need to use the actual internal HighWonder gate library to say how much forward to walk, how much diagonally to walk, how much should we be rotating, that's the yaw amount. We also have how much should we turn our head to the left and left-right panning, left and right panning. So there's a limit here of between, instead of from 0 to 1000, we're going from 125 to 875. And same with tilt, up and down. How much should we look down and up? And there's PIDs to track the ball or the target we're interested in with certain gains, P, no I, and some D gain here. And lots of classes, lots of different things. Here are some keyframes to look for the ball if we haven't seen the ball yet. Different places we can bring our head in, probably right, left, and up, down, and speed maybe of where the ball is. And different, we can specify the colors blue or red or pink. Later I actually changed it to pink because I want to pick up that pink cube, which is a nice beginner for picking up socks. Let's pick up the cube. And there's lots of services, cross topics, functions for setting this color, and what we do once we see and track the color based on many different nodes, color detection nodes, and we move our head towards that purple ball or pink cube. But at the end of the day, it's very messy, ugly, hard to understand code. We're doing, like, the HighWonder sadly was doing stuff like having 3 different variables. One is self.yawStop, one is yawStop without an underscore, and then there's yawStop with an underscore. And it doesn't, these 3 different things mean slightly different things, and then we're passing it to the approach object process function. And the third parameter is angle. The third parameter that we're passing in here is yawStop with an underscore. So it's horribly complicated to understand this code, and I'm rewriting and changing variable names as much as I can. But the main thing, as you saw, is that it works. It's able to kick the purple ball most of the time, which is impressive, and it's a good beginning to understanding how to do the visual servoing approach, which is probably the simplest way to play football or even pick socks. And there's a find ball, if you don't see the ball, then how to find the ball. The Chinese writing here, because it's HighWonder. Typically there's this main loop. We're looking for some kind of object. If we have found a purple ball, we're specifying that that's the ball data. And if we have a location that we're looking for with the right left pan of the head, then we're going to actually move our body towards that ball. And then if you haven't found it, it's almost time to start looking for the ball. With we're going to do a counter here to see, okay, now it's time to start looking for the ball because we haven't seen it for a while. And we run the find ball process. And lots of sleeps and shutdowns and stuff. But you get the idea, like, there's lots of little details in this body track process and approach object thing. But at the end of the day, we then choose whether to kick with the left or right foot. Once we're close enough and approach object is returned true, we disable walking, the gait, the locomotion. And if it's more to the right, we decide to kick with the then yeah, it's left right, more to the left, we decide to kick with the left, and same with the right. A lot of details there. I've been deconstructing it, but on a high level it kind of comes back to what I was saying about visual servoing, meaning There's like 3 different approaches what I'm talking about. Approach 1, sense, think, act. Approach 2, and maybe I'll order them in terms of ease. So this is approach 2, this is approach 3. And approach 1, I would say, is the easiest. I'm getting there because I already have some results I can share. And I simplified way too much by just saying if ball to the left, rotate left. But on some level it is that. With details of how much to rotate your head left versus your body left, and when do you stop? How do you decide that the ball is close enough? Cool. But as I said, soccer is not my main goal here. Soccer is my starting point from the high wonder code, the very messy code, very hard to understand code. But what I really care for is picking up socks, as I've mentioned in previous streams. I want to pick up socks. So obviously the beginning to that is to create a kind of keyframe action for socks. And I created a video on November 28th. Here in my daylog, I have this video on Notion that I uploaded. I sent it to a few of my friends saying we're in business. So this is more picking up to the left. And it's able to actually have a good grasp on socks. Socks are deformable, soft objects. They're not rigid. But because of that, actually, in some sense, it makes it easier to grasp it because there's a lot of surface that you can grab onto and get your gripper fingers around. That's what I did on November 28th. And maybe even show that live. Okay, let's try to find that script. I'm gonna run base.launch because I think I need the controller running. I'm gonna open a new script here, new pane, tmux pane, and go to, I think, the pick up one hand. Let's find where this is. It's in AI Next driver. Kinematics, source kinematics, yeah. And what do we have here? So pick up one hand. I'm gonna not show me and show the robot. Pick up one hand. Let's see. Yeah, is it doing the same pickup that you saw in the video? Yes. What happened there? Did it collide? Let's see again. I'm running. That arm is shaking a lot, which I worry. Do I need to tighten some screws? But anyway, I have a sock. I have a special sock with me. So let's see. Is this arm very shaky compared to the other arm? Maybe. I should tighten some screws probably. I hope Johnny doesn't break, but let's see if he can pick up this sock. That same script. No. Bad grab. Again. Let's put it into a little better position, more in the front. This is a keyframe based approach, which I'll describe in a bit. Alright, successful grasp. So that was kind of my first attempt at sock picking, because you need a keyframe action to at least see if, always simplify the problem. Can you pick up a sock? Even with keyframes, even with placing the sock under where you know his hand is going to be, where his gripper is going to be. So let's look at the code that achieved this. Some imports. I'm going to remove. Yeah, it's the only import of OS, so removing. Some ROSPy. I think we need SQL. And we have this motion manager part of HighWonder. We're able to like set, for example, the 23rd ID number, servo ID 23 to 500 pulse angle, which is both head pan and head up and down, head tilt to 500, which is roughly in the middle, so it's pointing forward, as you see down there. His head is looking forward. Anyway, then I just was manually changing and like trying different things in slider-based keyframe editing, and like choosing very specific angles for each single servo ID. I set many different motions, so specifying all of these different. The format is always the speed, and then a list of lists specifying servo ID and which pulse angle the servo should go to. So we have many different, specifying 2 different low squat arms forward. That's the first kind of keyframe. We have stand low, no gripper action, stand normal, no gripper action. We have, if I want to just open the gripper, we can send it to the 21st servo ID to 300, and the left arm, just only moving the left arm to go lower and to the side. And in the squat, I was changing, I was iterating here. There's the pre-pick pose, and then there's the left hand put block, and I have a function just to run a list of lists, and we do it in this order. And I'm not going to clean this code too much because I've moved on and I have a better script, but generally on some level it makes sense that we're just doing a bunch of keyframes, moving between them. So we're standing normal, no grippers. We're standing low, we're kind of doing a squat. We're doing even a lower squat with the arms forward. We're doing the pre-pick pose, which is putting the left hand over the sock, and left arm goes lower and to the side in squat, and then left arm is going to close. We'll go back to that original low squat, arms forward. We stand low, and then we end up in the same position as we began. Stand normal, no gripper action. And I could even like open the gripper, so we drop the sock if we wanted. So now that you kind of see that, let's run through. I'm going to make this bigger. As we run it, pick up one hand.py. Let's see as we go through all these actions. Stand normal, stand low, low squat, arms forward, arms go lower to side, grip, and yeah, back to normal. It all happens quite fast. Speed is set to 1000, so it takes 1000 milliseconds to do it, and then we sleep immediately 1 second right after to give it time to complete that action. That was my first attempt. That was the video you saw on November 28th and what you're seeing right now. And you can see it's able to pick up socks both in the video and live. Great. There was another script, but I realized the reason, motivation, but I realized visual servoing, how we're doing soccer is we're kicking with the left foot or the right foot when the purple ball is in front of the foot. So therefore I need a grasp action that will do the same and not just pick something on the side. I should pick it in the front. So I have another script called grasp in front. Let's see if we can run that and how that works. And this time it's on the right hand side for the right foot, the right hand. And this script is a bit more complicated. I'm implementing better ways of specifying angles. I don't want to specify servo IDs. I would actually prefer to specify radians, the actual name of the joint, like right shoulder pitch, specific radian, degrees, radians, the angle, instead of specifying a pulse angle, which is not intuitive. And this way I can actually test in the simulation first and then see if it works in the real world. I'm kind of doing a similar thing here. I'm doing a deep squat in the front, closing the gripper, lifting the arm up, and then I'm actually dropping the sock. So let's see if this works. But I need to go to grasp in front. You can see what I'm typing. Grasp in front. I have multiple scripts here. I might as well run. Well, let's see if Python grasp in front works. I'll swap the camera. I'm going to run it. You can see it. Let's see what it looks like. I do this Rio de Janeiro Jesus position. Then I've been experimenting with kind of changing that. Are we able to grip? Nah, I've changed it. I might need to revert to the commit that I did last, but I've made it worse. I was doing things with the elbow. I might just, yeah, I can actually just comment this elbow stuff. I was trying to get closer and closer to the ground. We are limited with 5 degrees of freedom. So if I just comment this elbow stuff, let's see what it looks like. Probably it's not as simple. And everything has interacting parts. Like the shoulder will affect the elbow's position. So I might have changed the shoulder's position. This is the deep squat position. I had actually this. Let's bring the single keyframe for a deep squat and putting the arm quite in the front. I was doing multiple action lines here. First doing this dictionary, then doing this dictionary. I'm going to comment this and just do the deeper arm squat. Let's see. Okay, we're back in action. Do we grip? And we do. And we dropped it by accident. So that was a failed grasp, or a half failed. You get half points for a good attempt. But it fell out while we were lifting. So can we get a stronger grasp? Actually, I was changing how much we're grasping here to minus 0.15 for the cube. But for a sock, it should be a bit tighter. So this is a bit of a tighter grip. So let's run it again. I'll give you the full screen view. Not bad. And now we open on purpose. It was a bit loose grip, but it was a successful grasp. So that's the grasp in front, which is what I wanted to be able to then do soccer. So here's the idea. It's do soccer, but instead of kicking with the right or left foot, do that grasp action that you just saw. And I thought that would get me to some form of accuracy with sock picking. But the perception of socks is also a little difficult, and I was trying many things there. And I just wanted to simplify the problem. I was even trying to build a click interface so that I'd be clicking all the time where the sock is and that it would get closer, but that wasn't working exactly. So then I simplified the problem even more. Let's try to pick up the pink cube. If you can pick up pink cubes, you're closer and closer to being able to pick up socks. So let's see. And I only have grasping on the right side. Just to reiterate, make sure that I'm covering everything we need to. So I've shown you was actually on the left. Pick up one hand on left and then grasp in front, what you just saw. And I give the robot a sock. I can give it a cube as well, we might as well, but the specific position matters. It's how brittle this approach is, the visual servoing approach. Better would be to do motion planning, etc., or reinforcement learning. But if I put the cube here, we can run the same. Put the cube there. Let's try and pick up that cube. I've placed it very conveniently there. Are we able to grasp? Ooh, bit of a tight. Oh, it was a very tight grasp, and then we let go. It actually worked. It was a bit awkward, like picking up something like with your pinky, but it worked. That's still a keyframe. So now I created kickball with kickball node without kick for my attempts to pick up the pink cube or to pick up a sock. So I'm kind of getting to this. And I was able to get 30% success rate out of 10 attempts on the right side with the pink cube last Thursday. So I'm going to show this. Let's see if it still works or if I've changed anything. I'm going to go back to kickball and we can run Rust launch kickball without kick node. Very stupid name. I'll change it to pick up cube or pick up sock autonomously. Let's see if this works. I can also show Orviz view as well. Let's see. I always like seeing the first person view. Yeah, we killed the base pane up here because there was a conflict of two different controllers running at the same time. Control Z and run again. Let's see. All right, we're moving. We see a cube. And it's on the right hand side, which I'm hopeful for. Let's see how close we can get. We kind of pushed it away. We actually picked up the sock for the first time autonomously without meaning to, because it was close. Now it's on the left hand side and we actually don't run the left action. So every time I'm moving the robot with my hands just to make sure that he goes with the right foot to run the grasp in front. Okay, we're on the right side, very good. I'm actually going to change what I showed you in the code that I was changing for sock. So the -0.6 was for sock tighter grip, but the cube needs a less tight grip. So we've changed this grasp in front.py. And let's run it again. Gonna go to the left side. Again, I have to move them. And I put them a bit further away to prove that the visual servoing of at least getting to the cube works. Ooh. What a good grasp. And that was a good grasp. That was a success. Let's show another view of this. Yeah, he's trying to run the left kick, but I've disabled that. So again, as I said, I'm moving him away. Start again. Kind of pushing them a little towards the right side. It'll be very easy for me to create the same grasp in front and have a parameter for whether it's a left side or right side. Right now I'm just doing a proof of concept. Ooh, bit of a fail there. See, it's on the left side. So not too high in accuracy, but somewhat works. And we're kind of hoping and praying. Let me get close enough. And I would like the arm to get closer, but still not perfect. Kind of slips a bit on the floor with those metal legs. This looks like it's going to be a good grasp. Oof. Yes! Success! And again, I show you the Orvis view. Yeah, oh, he kind of fell out of his hand there. And I'm printing the X and Y position of this object here. Can't really see. I'm printing the XY position, printing all these other very obscure meanings from the Chinese High Wonder Company code. I'm going to rename all these variables, but right now it's trying to do the left shot because you can see the cube is closer to the left foot. And we're deadlocked here. But if I move the robot, it'll try again. So it's continuously trying to run the left shot action. Different angle. It's the left side, it's down on the right side. It's walking. Ooh, that was a very close grip, but not good enough. Anyway, you get the idea. This is roughly 30% accuracy with me moving the robot so it gets on the right side. But it highlights that visual servoing can somewhat work, and I could maybe tune it to get to 80%. I don't know if it can get to 100%, and also not super confident on if it could work amazingly for sock picking, but that was a good grasp. And he dropped it over there. Nice. He even threw it over there. Okay. You get the idea. But it is kind of fun to look at. Voltage is 11 volts, which means we still have some time before battery runs out. Oh, that was a fail. Fine. Ha! That's a good grasp. Ish. Maybe fell while I was lifting it. Someone actually sent me a chat. Ask me what's the meaning of life. I'll say humanoids. Or Johnny. Johnny is my meaning of life. Okay, you get the idea. So, where does that leave us? I've talked about soccer. I've kind of made some bad, I could have expressed it better, link to how I'm going to make soccer visual servoing be a sock picking robot with visual servoing. Similar kind of just run the action. If you just get to the purple ball, the sock, the pink cube at your right foot or left foot, then just run the action of grasp at your right foot instead of kicking with your right foot. That's my visual servoing approach. Very simple, but highly complicated on some level. I've talked about these 3 different approaches. Typically, soccer is done with motion planning, state estimation. I could do that. I could try to use segmentation to find the sock and find the XY location, pixel location, and then do find a point cloud of the sock with depth estimation and plan many footsteps to get to the sock and estimate where the robot is and where the sock is relative to the robot. It's highly complicated. Could take time. That's why I'm doing the simpler approach of just visual servoing. And of course, there's the whole other approach that is possible but needs a lot of GPUs and simulation time and proper specification, and you have to solve the sim to real problem of then how to transfer from the simulation to the real world, or you can train in the real world, which is harder, but a lot of papers are showing that that is possible. I showed these sock actions, and I keep talking about this general problem of sock picking, is that's soccer, but I think it also applies to sock picking, and it also applies to how do you solve problems in the home. I mean, there is another approach that I haven't talked about, which is approach 4, imitation learning. And that is actually the most successful approach when it comes to humanoids at the moment, with Tesla, Unitree, Phoenix, Apollo, is that people are wearing these VR headsets with different things, and they're controlling humanoids with VR headsets on to do certain tasks. It's also the kind of ALOHA based. This is not VR, ALOHA, but a human is controlling this to do a specific task. They're using the follower leader arm to control the follower arm and able to do many different tasks. And they collected hundreds and thousands of hours of data to do specific things. There was also very impressive was actually shoelace tying. This is in the simulation. Racking plates, cleaning pans, picking up a hammer, passing the hammer to the other arm. There was mobile ALOHA, which a lot of people complain that it's often teleoperated, but they show also that it can be autonomous. So this is probably teleoperated, making coffee, emptying a dishwasher, sushi, playing with the cat, chips. I mean, don't think the world is ready for these things actually working as well as they could soon. Taking out the pod and softener for the washing machine. This is all teleoperated, but wait, do we have some autonomous demos later? They even do shrimp later on. They definitely did shrimp. Cooking of shrimp. Compilation of autonomous skills. That's the important part. Autonomous. Well, there was teleoperation, but with a human controlling it. But this is actually autonomous, cooking a shrimp. Bit of olive oil. 3x speed, but I'm going to 2x it. So 6x speed. Cooking a shrimp. Putting it onto the plate. Calling an elevator autonomously and getting in. The full thing is autonomous, even the mobile base is differential. Wiping wine, high fives, autonomous, so useful. Pushing chairs, and the classic example that the last 2 chairs were out of distribution, but it just kept going. It just saw more chairs that had to be pushed under the table. Amazing generalization. So I'm being somewhat sarcastic, but it is also somewhat impressive. Putting pots into cabinets, not bad. I bring all that up because imitation learning is the most successful what's the early fruit? Low-hanging fruits way of making robots / humanoids to do thousands of things, and that's kind of a key word there. Now, will it generalize to every home? Can it make a coffee in every single home? That's the Steve Wozniak coffee robot test. From bringing the coffee test from Steve Wozniak from Apple, which is a machine is required to enter an average American home and figure out how to make coffee. Find the coffee machine, find the coffee, add water, find a mug, brew the coffee by using the proper buttons. I mean, LLMs have enabled a lot of the common sense needed to do this, and where to even look for the coffee pods. Maybe try every cabinet. You've tried the first cabinet, try the second cabinet. Some of that common sense is finally getting here, and then we need the dexterous manipulation to be able to open cabinets, not fall over while you do that, and then look for what the perception of, is that a coffee pod? Obviously, it's the pod-based approach. The filter coffee is way harder. If you're just talking put a pod in the machine, then that's easy enough. I don't think there was an example. There was an example of coffee here with the pod, I think. I can't find it again. I mean, and then the company physical, and there's a coffee. It's putting a pod in. There's teleoperation. Yeah, everyone has examples of this. Even Figure has an example of this. Shaving. Yeah. I lost my train of thought. But imitation learning works. End of story. But does it work well enough to generalize everywhere? The lovers of this approach would just say collect more data. And yeah, I remember now, physical intelligence, Sergey Levine, who I've been following for for 10 years probably, they're building a generalist policy to do everything. This is autonomous 1x speed, and they just believe in that it can generalize. That is, we've seen it with GPT. Will robotics have the GPT moment? Just show it enough coffee machines, show it enough pants, show it enough tasks, and your home, your coffee machine will be in the distribution. And folding laundry is quite annoying. If a robot could do that, that would be a big market. As I said in the previous stream, it's not a question of if they'll do it, it's just when we'll have robots folding our laundry. Dealing with eggs. These are the same ALOHA arms. Cool. Anyway, imitation learning works. The problem for me is to do imitation learning, I need to build a teleoperation system, either with camera, RGB versus RGBD, or VR. I could buy a HTC Vive kit, whatever it takes, to control Johnny to do certain things, e.g. pick up socks, collect enough data, and just run ACT or diffusion policy from ALOHA on, maybe you guys can't see this too well, I can make it bigger, my face smaller, zoom in, on this data until we generalize within a large enough distribution. It is an approach, but it needs a lot of setup, and way more setup than me just doing visual servoing and saying if suck to left, go left, and if suck at your left foot, activate left gripper suck, activate left grasp at your foot action. But I want to go through all these approaches, and it's what's necessary for humanoids to be able to be actually useful in your home. Cool. And we kind of covered all the demos for today. I can talk a bit about my journey here over these 3 months, like a retro recap on November. So I received Johnny, small beginnings, and I have like a retro here, what I achieved in November. I have all the videos here. This is a public page, by the way, that I'm sharing here. View site. Try to put it in the stream somewhere, or editing these videos for YouTube as well. So let's go to November retro. Cool. So yeah, the first stream was about me unboxing Johnny and starting to study and run through all the code that Highwonder had. Highwonder's code. Many things I can show in future streams. Initial results. I was running Orb Slam 3 with RealSense, but also sending images from the rolling shutter camera of Johnny that you see here to my laptop, which was running. And that worked somewhat. I'm quite impressed. There's some network latency, but also the main problem with Orb Slam is that it loses track so easily, especially with a bad rolling shutter camera. And better would be to do visual inertial, use the IMU with the slam. But still, you'll have the problem of losing track. We could talk about all these topics for hours, so I'll kind of run through. We talked about picking up the sock with the keyframe on the left-hand side, and not in the front. I was trying more Mujoko simulation. I'm learning about forward. I'm still learning here. There's so much topics within humanoids. So learning about dynamics, inverted pendulums, MPC, especially from Russ Tedrake's course. And I went to Humanoids 2024, gotten even more hyped. I'll another time show this face follow and come to Papa. Another time I can show the middle and the front splits. Front splits doesn't work that well, but middle splits, yes. Cool. That was the retro recap of November. It was a good first month. I'm ramping up. December, retro. Because it was Christmas holidays, I had a lot of extra time. I was doing a lot of this motion retargeting, so I'm able to teleoperate Johnny one day to do specific tasks through camera. We'll see how accurate that could be, but there is lots of reports of being able to use the camera to teleoperate humanoids. I got it working in the side plane, not the front backwards plane, in bio terminology. And I also tried some inverse kinematics based motion retargeting. I've been working on this imitation learning with ACT from Tony Zhao and LeRobot's implementation of ACT. Early days. Went very deep into inverse kinematics. Even random descent, which is just try random configurations and then choose anything that improves the position, the end effector position. Different versions of differential IK, gradient descent. IK, Pink and Mink have their own versions of IK using teleop sliders, random goals. Still have some struggle with kinematics working everywhere, but I think that's common and it's improving. I'll talk about actually picking up microphones in simulation with G1 and trying with AI next, Johnny, and then dropping the mic. Deep into PyBullet. I've always loved PyBullet more than Mujoko, the simulation, and tried a bit of Genesis, this new simulation that came out in December. I've been playing with reinforcement learning. I did a lot in 2018. Now I'm back at reinforcement learning. Just at this, created my own environment to look at this red sphere. It's like a first-person shooter, and just the goal is to look at this red sphere and getting better at TensorBoard and weights and biases and configurations and reinforcement learning experiments. All of that's necessary if I ever want to try, which I do, already have been doing, making Johnny do reinforcement learning, to walk, to stand up, for example. Everything I was showing in the workshop, for example, they do reinforcement learning for footstep planning, they do reinforcement learning for locomotion, walking, they do reinforcement learning for fall recovery, stand up, etc. So I want to get deep into reinforcement learning because it does work when it works, and you design your reward and design your environment and design the simulation so it transfers to the real world. I did my second Twitch stream, edit the first, and actually scheduled the second, and it was posted today on YouTube. I can actually show that. So I'm posting all these two streams to my channel. Let's go to my channel. And this was posted today. What can Johnny do? I kind of edit them down. This was like 39 minutes, and it took me a few hours to edit it down to 31 minutes. Somewhat worth it, but keep trying to edit and find the right balance here of streaming and editing and posting to YouTube. And I've made some hardcore convictions. Some of what I've been saying right now is that imitation learning works in the story. Will learning in the long term be just the bitter lesson from Richard Sutton? In the long term, learning or approaches that can use computation will scale the best and beat approaches where we try to put our own engineer's knowledge into the system. I would say motion planning and visual servoing are approaches where we're trying to put all the knowledge we can into the system that we think would help, but as DeepMind proved, learning wins over the long term, especially for soccer playing. I've played around with GPT-4 and using Whisper to talk speech interface to Johnny. I'm like, wave for us, Johnny. I'll get to that later. I was trying to reproduce this Okami paper because I believe third-person imitation is the future. I could spend a whole stream on just this. This one. The humanoid watches a human perform the task. Pick up. And there's a whole pipeline to reconstruct the human, decide which object is being manipulated, retarget to the humanoid so we can pick up the same bag and put a certain object into the bag, and it can be with one demonstration, I think, or more. It's able to then copy from third person, not just first person, how to put items into a bag for closed loop visual motor policy. This is autonomous. And that was in Coral. I want to go to Coral 2025 Robot Learning Conference. Debugging the visual servoing for kick and ball. That was in December. And I always have this problem with URDF versus the real world. I'm going to talk more about that soon. There's some issues with the URDF, but I've fixed many of them. I'm obviously doing many different things because there's so many elements to humanoids. So I'm having a lot of fun, but also I need to focus and think what my goals are. And obviously, the more socks that are picked up, it's a good KPI to hit and a good way to simplify and focus everything I do. That's the December retro. Coming back to what I planned for today. I've recapped November, recapped December. Kind of spoiling some of the things I'll talk about in the future. And my plan for January is, it's opening the page, but it's up here. My plan for January was at least these 5 goals. I'm making progress on some. Start picking through any means. As you've seen today, I'm getting somewhere. With the red cube, it was a 30% accuracy. Now I just need to make it a sock rather than the cube, and I will have achieved this goal at least, and then we can aim for a higher accuracy later. I tried this clicking approach. Didn't work. Have to analyze further. Maybe that's what I'll need to do to make the sock picking work. Later, in February, for example, we can do the full perception of finding the sock and then all of that, but I don't consider that to be too big a challenge. For now, I could be wrong. There was this big discrepancy between the URDF, the simulation file, the how we specify all the links and joints of the robot in simulation with compared to the real robot. We can spend whole streams just talking about this. I'm able to do many of the actions now in simulation that are the same as the real world. I fix many problems, but actually the robot falls more in the simulation than in the real world. Something is still wrong there. I might need more system identification to highlight what is the difference between the real world and the simulation. And eventually I want to even make Johnny grip socks or cubes in the simulation, but even that I was struggling with because the URDF of the hand, something's wrong there. I might need to build a simpler model of the gripper. And then what I talked about, if I ever want to get to imitation learning, I need a way to teleoperate Johnny somewhat. I could use a space mouse or a specific mouse, or slowly use teleop sliders to make him pick up things, but it's still really hard to make him do things. The best teleoperation interface is me with my hands controlling and seeing Johnny do things that I'm doing with my own hands, with VR, HTC Vive, Oculus, or with actually RGB camera, you seeing where my hands are. I've done a lot of work on this, but still not there for fine dexterous tasks. Like picking up cubes, that's not that dexterous, but I've done this kind of motion retargeting in the sagittal, or the coronal plane, but now I need to do it in the sagittal plane, forward, backwards. And I want to do imitation learning not just in the simulation with these full arms that I'm talking about, but also just with a servo. Like, for example, a stupid, simple application of a servo is to point. There could be a flag on the servo, and it needs to point the flag at a specific target. You could obviously do that through classic control and planning, but you can also make imitation learning do this with enough examples. So I want a servo to point its flag at a specific target. And let's see, with 5 demonstrations, 10 demonstrations, am I able to run through the LeRobot or ACT pipeline, save the data, learn on the data, and make the servo point at a red or green target, for example. Should be very simple, but it builds the pipeline. It's only 1 degree of freedom, but the pipeline then should work in theory for 5 degrees of freedom, for 2 arms, 10 degrees of freedom. And that's what I mean by this 2 arms thing. And yeah, that's what I'm talking about. Once you have the data, you can imitate to then create this autonomous policy. It starts small, but escalates later. We're on January 12th, so I have some time. I've been doing some things in reinforcement as well. Even if I could just get them to stand up or not fall or walk, that would be very interesting. I did some things in Genesis, the simulation, that came out of the box, the tutorials, and they're able to train a quadruped to walk in 90 seconds with massive parallelization. I was able to do that in Lightning AI with free GPUs. So if a quadruped and even a humanoid in Genesis is able to walk after just a few minutes with enough parallelization, can't say that word, Johnny should be able to do the same. And then you just keep scaling from there. It's a lot of goals, and I have all these extras as well, but these are the main priorities because I want more and more socks picked, and then once we get the socks, we can talk about other goals and other tasks that humanoids can do later. Cool. That's a lot of information, but I'm just giving some spoilers that I have many things to talk about in the future. That kind of... Is there anything I haven't covered this stream? Like I mentioned that I've mostly fixed this URDF. So most of the actions that I do that I showed on the last stream of the robot hurdles, walking, kicking, they do the same thing in the simulation, but physics affects the robot differently, so it falls over often due to there's some mismatch between the URDF file and the robot. And as I said, we're picking up cubes at 30% accuracy. So that covers the last 2 months and what I'm doing this month. And giving you a lot of information, but it's a very exciting field, and not enough people are talking about it. We laugh at it now. He's just picking up socks. Our humanoids won't scale. There's a lot of people who say it won't work. There's a lot of people are worried for their jobs and the future of that when it will work. So I'm kind of chronicling with my robot how difficult it is to make the software work for these very simple tasks that later can scale to more tasks. And it's fun. Again, that's why I'm here. Let's make Johnny pick up more socks. Lots of progress, and that's it. It's been fun. Thanks for watching.